Okay, let's go through this question. This question you asked me yesterday. So we have these two loudspeaker connected to the same signal generator. Then the speaker is being separated by 0.5 meter, right? Then of course the screen. Let's just say there's a screen here. So the screen is 5 meter away from the two loudspeaker. So we are asked for the part 2, estimate how far the observer would need to move towards P in order to be at a position where minimum sound intensity would be detected. So means that this thing is your DI, destructive interference. So in order to have DI, right, always remember the condition. So DI must be equal to the path difference. In terms of the path difference is like that. Path difference between the two wave, right, must be about half a lambda, 3/2 lambda, etc., etc. So must be a non-integer. But of course, you must also look at the initial condition. For example, they tell us that the observer at A identify the position where the loudest sound is being heard. Means that when you are at this point, first and second, right, where the path difference is 0, so this one is your constructive interference. So meaning that L1 and L2, they are actually initially in phase. Okay, so with this, right, let me just help you, to solve this question. Okay, first thing, we are asked to determine where is the first minimum. So estimate how far the observer would need to move, right, in order to hear a destructive interference. So first, let's just say my DI is here. So, okay, here is DI, right? Okay, so from the loudspeaker, first loudspeaker, there's a sound wave here. Then the second loudspeaker, there's another sound wave here. So you realize that if I draw a dotted line here, so this part here will be known as your path difference. So this is path difference, delta x. And this delta x is actually so for example, I draw a 90 degree here, then there's a theta here. So this path difference is known to be sine theta, right? So it's 0.5 sine theta. Because you look at this part is your opposite, then the 0.5 right here, right, is actually your hypotenuse. So the path difference between the two sound wave is 0.5 sine theta. And we must know that, at this part, right, is half a lambda. Okay, so let's see how do we do it. Okay, first, d sine theta half lambda. So your lambda, you use v equal to f lambda first. So my v is 340. My frequency, right, is given as such, about 6,000 hertz. So my wavelength is quite small, definitely. So 340 divided by 6,000. So this will give you about 17,300 meter. So you just need to multiply with this thing. So this part will be 0.5, right? Okay, 0.5 sine theta. Then half times 17/300 is about 17,600. Then after that, you just find what is sine theta. You understand why I want to find sine theta? About 17/300. So this is your sine theta. Then after that, I want to find your theta. So sine inverse 17 divided by 300, right? So it's about 3.2485 like that. 3.2485 00973 degree. Okay, so what is this theta? This theta is actually this theta right here. Okay, let me just erase this, then you will see already. Okay, then after that, right, since I already get my theta, so now I want to look at the horizontal part already. So there's a horizontal part, and I assuming that I draw one triangle right here. So there's one triangle. So this part right here is also known to be a theta, which is equal to about 3.2485 like that. Okay, so based on this theta, okay, I can actually find what is this part already. Because I want to find this part, I want to find what is the distance traveled by the observer A, such that he will hear the first minimum. Okay, so my theta here is 3.2485 degree. So I want to find oppo, right? This oppo. Apparently I got adjacent here. So adjacent is about 5 meter. So I can find the answer. I can get the answer already. So based on this answer, I can use tuaka, so right, tan. So tan 3.2485 degree is equal to oppo over adjacent, which is 5 meter. So oppo is actually equal to, let me just do a fast calculation, 3.2485 times 5. Yeah, so it's about 0.2837. So roughly round off to 0.284 meter like that. Yeah, so that is how we actually solve this question. So this question involves a bit of the similarity of triangle lah. Because if I let me just draw again the triangle here. So I draw the initial triangle, right? First triangle, second triangle. So apparently if I draw this part, so this black color triangle is actually similar to this light blue triangle that I draw here. So that is how we actually solve this question.